So for your topic on this, you're gonna write up top that the topic is proportional equations. Proportional equations, okay? That's what you want to write on the topic. And the reason why this is called proportional equations is because when you set two fractions equal to each other, that's what this is. This is a fraction and this is a fraction. When you set them equal to each other, notice, guys, there's the equal sign in between. That is called a proportion, okay? The way to solve a proportion, the only way to solve a proportion is to cross multiply, okay? Everybody write that. Now, I don't want you to get confused between multiplying fractions and solving proportions. When we multiply fractions, we multiply straight across, right? Top times the top, bottom times the bottom. That's when we're multiplying fractions. But when we are solving proportions, meaning two of my fractions are set equal to each other, what I'm going to do is cross multiply, okay? And so what that means when I cross multiply, it's saying, hey, I got two fractions, A over B, set equal to C over D. And to make an equation, I can cross multiply these fractions. I can take A times D, and I can get AD. And then I can take B times C. I'm multiplying across. It's equal to BC. And that helps us because once we do the cross multiplication, this looks just like an equation, right? It looks like everything that we have been doing. There is no confusion. It's all the same. So our second step after we cross multiply would be what we typically do. Remember, distribute if necessary, combine like terms, and solve, okay? So we would distribute. You always will look to see if you can simplify by combining like terms, of course, and then you would solve. So the big key for us is to remember the golden rule in red, which is this first step. When I see a proportion or two fractions set equal to each other, I am going to cross multiply. Are we all on the same page? Let's practice this with the guided examples above. Example number 1, 4 over 3 is equal to x over 6. Now I got to solve for x, Deliani. I see I got two fractions. They're set equal to each other. So this is a proportion. I am going to multiply across 4 times 6. That's 24. And then that's equal to 3 times x, or 3x. Now if I look at this, Tia, this is easy. I can solve this, okay? I go back to my regular steps. Distributing if necessary. Nope, we don't need to distribute. Combine like terms if necessary. We don't have any like terms to combine. So I can go straight to solving for x. In order to solve for x, I got to get rid of this 3, right? So I would be dividing both sides by 3. And I would end up with x equals, and in this case, x equals what? What does x equal? Come back to me. Come back to me from Thanksgiving break. I see you e-learners in the chat. Yes.
7.
Close.
8.
8. 8.
Oh, I was going to say,
X equals 8. Good job, guys. Yes, come back, guys, come back. Long break. Number 2, example number 2. Is this a proportional relationship, yes or no? Do I have two fractions set equal to each other? Look at it. Is it two fractions set equal to each other? Yes or no? Yes. Okay, so even though this fraction is a little more complex, right? It's more complex than this over here. It is still a fraction. So I have a fraction here, 2 over 10. It's equal to a fraction here, 4 over n plus 5. So these fractions are still set equal to each other, which means I have a proportion, which means I need to cross multiply. Okay? I'm going to multiply a 2 times a n plus 5. Now be careful when you do it, guys. Do not write this. This is a big no-no. Do not do 2n plus 5. Is that correct?
No.
No, it is not. No, it is not. You need to multiply this 2 by everything, which means I'm adding my parentheses in. I'm taking 2 times the entire quantity n plus 5. Okay? The next step, I got a 4 times 10. Cross multiplying. I know that's 40. Now, I have cross multiplied. I go to my second step, right? Which is distributing if necessary. Now this looks like something I can deal with. Distributing, I know I have to do the distribution here with my 2 to the n plus 5. So I got a 2n plus 10 equals 40. And now I'm going to subtract 10 on both sides to get n by itself, because this is looking good. I can go ahead and solve. Subtract 10. And I end up with 2n equals 30. And then I'm going to divide by 2 on both sides. And I end up with n equals 15. Not so bad. Is everybody seeing the key to make this easy? The key to making this easy is knowing to cross multiply. If you forget cross multiplication, you're in trouble, right? E-learners, how are you feeling? Are you seeing this? Key to make this easy is cross multiply. If we forget cross multiplication, we are in a lot of trouble. We're in a world of trouble. E-learners, give me some feedback. Let me know how you're feeling. Awesome. Thank you, Tia. What about the rest of you? Olivia, Uretzi, Davina, Xavier. How are you guys doing? Awesome. Okay. Hey, guys, look at this next one. It is, again, another example. This is another example of a proportion. Okay. So to solve the proportions, we're going to cross multiply. Even though this fraction is complex, I see 2 fractions set equal to each other. That means cross multiplication. So I'm going to multiply across. Okay, I'm going to multiply across. A 5 times y minus 3 and a 2 times y. Remember when I write the 5 times y minus 3, I put the y minus 3 in parentheses. Okay. 5 parentheses y minus 3, and it equals 2 times y. Does everybody see that? Please, please, please don't forget your parentheses, okay? And with that being said, here's the easy stuff, okay? I am going to use my distributive property to distribute that 5 inside of the parentheses. I end up with a 5y minus 15, and it's equal to 2y. Now I'll go to my next step, which is just solving. And guys, we have a problem, a situation here. What do we need to do? I got y's on both sides. What do I need to do? Yes. What do you want to do? How do I do that, Deliani? Yeah. And what am I going to do? If I'm adding 5y, I should do what? Yeah, I got to subtract 5y on both sides of the equation, right? So, I mean, you're saying the right things. We want to get the y's together. So that means I got to subtract 5y on both sides of the equation because I want to move that 5y to the other side, right? Putting them together. Okay, so to the left side, the 5y's cancel. And I have negative 15. And it equals on the right side a negative 3y. Awesome, Xavier. Awesome, Davina. Yes, you guys are right on point. Perfect. Now, I need to divide by negative 3 on both sides to get y by itself. And guys, this is a big thing that I see you all doing. Don't forget your negatives. Like a lot of you will just divide by 3. Like you'll get all the way down here and you'll forget your negative sign. Please don't forget your negatives. Okay, a negative divided by a negative is a positive. So I should end up with a 5. Y equals 5, right? Y equals 5. All right, last one, guys. Remember, even though this is more complex, this is still a fraction, okay? It's more complex, Alejandro, but it's a fraction. Over here, it's set equal to another fraction. I see 2 fractions equaling each other. Instantly, I think cross multiplication, okay? When 2 fractions equal each other, you guys, we gotta cross multiply. So I'm going to cross multiply 2k minus 3 times 5. When I write this out, remember, I'm putting 2k minus 3 in parentheses because I know all of that needs to be multiplied by my 5. Okay? That's equal to, and then I'm going to cross multiply here, k plus 9 times 3. Again, I'm putting k plus 9 in parentheses because all of that needs to be multiplied by 3. And when I do that, I'll go ahead and look at my next step. Well, this looks like stuff we know. I need to distribute. Okay, I got to use my distributive property. So on the left side, I got to distribute the 5 to the 2k and the negative 3. So I got a 10k minus 15. And on the right side, I set it equal to, well, I got to distribute the 3 throughout. 3k plus 9. So I end up with a 3k plus 27. And then we have to do the same thing we were talking about before. I got to get my k's together. I got to get these numbers together. First, let's go ahead and get the numbers together. I am going to start by adding 15 to both sides. Okay, so I'm going to add 15 to both sides. A 27 plus 15 is a 42. And the 3K comes down. So I got 3K plus 42. And it's equal to, my 15s cancel, and I got a 10K. Now I got to put the 10Ks together, which means I want the Ks on the other side because I want to get K by itself. So I'm going to subtract 3K on both sides, and I end up with 7K to the left equals 42, right? My K's cancel. And I got 7K equals 42. Then, to get K by itself, I divide by 7 on both sides. And so we know K equals 6. K equals 6. What does the next part of this sheet say, guys? What does the next part of the sheet say? What does it say? You try. I am going to give you guys some time. You're going to work through the next problems, and you are going to try at the solution. You are going to try. So pause. Those of you watching the video, you're going to pause the video, and then you'll review the solution. Face-to-facers, e-learners, you'll go through, try the problems. When you are done with problems 1 through 6, type done in the chat. Face-to-facers, when you're done with problems 1 through 6, just give a look up at me. Okay, guys, we just went over the answers, but I want you to take a second and check your work. Check your work to make sure you are working the problems correctly. All right? Take a second to check your work and make sure you're working the problems correctly.